So hello and welcome friends to our channel Intro Mech, where we discuss about basic mechanical engineering concepts and many other things which are related to industrial automation. So guys, we have started our new series related to industrial robots, and in our previous sessions we learn about basics of the robots and different terminologies, and then we started looking into what are the different configurations of the robot. So we just learn about the Cartesian configuration, the polar cylindrical configuration, and today we will focus on what is the articulated or a jointed arm configuration of the robot. So without wasting time, let's get started. So you can see the image on the right hand side from which able you are able let's check if you are able to find out the motions. So here we have T, which is like a twisting motion, then we have rotational motion, then again rotational motion. So the articulated robots are basically designed to have few as two joints or as many as 10 joints also. So basically the typical articulated robots have 4 to 6 axes, and they are known for the most degrees of freedom. And those are well known for having most degrees of freedom, then relative range of motion compared to any other of the uh, configurations that we saw. So what are the applications? They are used in almost all the fields like part handling, then we have insert loading automation, cell automation, packaging, palletizing, stacking, sorting. So you can see almost in all the applications they are widely used. So here you can see the motion, they we have the different joints and the links, and all the links are having the rotational and twisting motion. So you can see it acts as a motion, is having like a human arm system. So they are connected with the rotary and twisting joints. So these are nothing but the articulated robot. So here we can see the work envelope. So these articulated robots are having different configurations, and that's why they have large working envelope related to the floor space it occupies, and the shape of the working envelope depends on the individual design. As we know, like these articulated robots can be configured in different ways. They can be having two joints, three joints, like four axis, six axis, seven axis. So depending on that, their work envelope can vary, but here we can observe the work envelope. We can see this is like cross section, you can understand, and this shows the 3D space. And as we learned about the restricted space, then the working space of the envelope, so here you can clearly observe like this is some space in which there is a movement of the arms, and that's why it is a restricted zone. So this blue color zone is the actual available working envelope, we can say, in which uh, we can have our activities, like whatever task we want to perform. So you can also understand these things: the restricted zone, the maximum work envelope, the maximum horizontal reach, the vertical reach, and here you can see the shape of the envelope. So this is very important, because whenever you select the six axis robot, let's say, you need to check with what are its dead zones, because the arms cannot move in those zones. They will be having the restrictions. So let's type a Fanuc in Google. Fanuc is one of the leading manufacturer of the robots, and it's a robotic company. Along with that, we have Kuka, Baby, Yasaka. So these are different manufacturers of the robots. Let's check out with Fanuc. So here you can see the different products of the Fanuc. You can go in on to the products and the robot. So you can see the different categories, the different models. So obviously they will be having different payload capacities. So let's check out one of the robot which they are offering. So basically we are looking into the articulated robots. So this is a small and medium size robot, so depending of its reach, so you can see the control axis, 6 axis, it has the maximum payload at the wrist. You can see 7 kg, 4 kg, depending on the model. You can check. Then the motion range, that is nothing but the horizontal and vertical range you can see. So you can see the X and Y, so that indicates its horizontal and vertical maximum reach, right? We can see the different ranges over here. And then we have the repeatability, so you can see it has 10 microns repeatability. Then its own mass installation, you can see floor mounted, or you can also mount it as upside down. So these are some of the information. You can read the brochure over here, and more information is given over here. The capacity is from 4 kg to 35 kg payload it has, depending on the size. And here comes the work envelope details. So you can check out the operating space, the actual space which is available, the maximum space, the restricted space, and the operating space. So you can see the envelope over here. And when you download the 3D CAD, then also you can create the work envelope, or some robots are having the inbuilt work envelope, so you can check that out. So so here we can see the work operating space, and let's check out some of the parameters over here. So again, we can see the axis, the control axis are given, the reach is given, and then we have the motion range, the maximum speed. So as it has the joins the J1 J2, we can see their maximum range, and in the bracket the maximum speed is also given, and the maximum load capacity, allowable moment at a wrist. Now these things are important while designing the end of arm tooling, because they will have some moments, and we need to check whether the wrist joint can take up those loads or not. And these are the inertia loads, as the robot moves at high speed, so we need to take into consideration the inertia loads also. So that's how we need to check the moments on this wrist, these axis. Like you can see the J4, J5, J6, and basically the J6 can be a wrist, so we need to check for the moments. So this is about the articulated or joint arm configuration of the robot. Let's check out the application. So this looks like automotive line, and we can see we have different robots over here for different applications. Now here you can see the end of arm tooling is picking up the automotive part, and it is placing at some operation. Then again it is picking another part, so it is picking at a time two parts also. So according to the application, we need to design the end of arm tooling. Now here we can see another application, it is applying some adhesive. So this is another application. So here we have the adhesive guns all over, and then it is applying some side structure. So these are different kind of applications in which the 6-axis robots or the joint arm articulated robots are used, and they are very widely used in the automation industry. So this is all about articulated robots, and if you have any doubts, please do write into the comment section and we can discuss over there. Until then, keep intro making. Thank you for your patient listening. Thank you.